Summary of the top lesson 3. Okay, so the first part we actually do was to do topic 2. Intro is to practice on whatever we learned on hydrostatic, if you remember, and then the difference between specific weight and gravity. And after which we go into topic 3, which is the submerge in terms of basic shape of plane surface and curved surface. And then we talk about a lot of things on inclined plane and the amount of formulas. Okay, so we talk about give me a while. I'll show you about how to derive this formula. Okay, from P equals to from force equals to pressure times area. We talk about how to derive this formula, and this formula has to be in a formula sheet. Okay, in your brain itself. It's a very important one. And then also this relationship. Okay, the torque divided by force is equals to perpendicular distance. So therefore this thing is actually this thing. And then the first is to find the perpendicular distance from a datum point. Okay, so so this is the force, the resultant force. The location is just, this is the distance, perpendicular distance. Sorry. Okay, so this is the perpendicular distance d. Okay, so force times distance, you'll get some motion in this manner, right? Torque. Okay, so this is what I'm talking about. So we're actually finding this y, because the position of yr is yeah, right. So the y and the yr is different. So what I'm talking just now is actually yr. Okay, because our purpose is to find yr in the end. Yr is the position of force r. Okay, yeah. And then after which we talk about how to deal with curved surface. You have to actually define, instead of resultant force being perpendicular to the to the plane itself, inclined plane, you have to actually know how to you have to actually split up into force in the x direction and force in the y direction. And then for x direction you use the same formula. Okay, the same formula must be in your brain. Okay, the same formula. But for y direction wise, you have to use the rho gh area times area. And then the key thing is that make sure, so the tricky part for both of this scenario is that you have to know where to sub your limits for fx, and also nonetheless for the inclined plane you have to know which limit to sub. Okay, which limit to sub. As for the forces at the y direction, okay, you have to know which h to sub in. Okay, whatever your area spanning. Okay, so this is the area, right? The forces acting on a piece of the area itself across the whole height. Okay, the whole span of the sheet. Okay, this is the whole sheet. Okay, so hope you get what I mean. And therefore you get a resultant force using trigonometry. And then to find the location is rather a little complex. So you have to, not complex but others, yeah. Anyway, so this is the same equation as the inclined plane. So there's no doubt about it. Okay. But for the this is location of fx. Okay, location of the force in the x direction from the water surface. Okay, so it's like, similarly, this is the force, this is the perpendicular distance, and then there will be a force, this whole ship will actually move. So this is what it means. So the position you have to make known. And then for the position of y, it is referring from position B, okay, from the depths of the water, the ship itself, because you are dealing with F equals to P area. So this one is in terms of rho gh, and therefore when the h comes in, you're dealing with the depths of the water. I would say, I may be wrong. and then the concept of CG. Okay, the concept of CG, we have to multiply into the area. So to speed, this is the different shape. You're just multiplying CG of the shape. Let's say CG of this quarter circle multiplied by the quarter circle area, and then the CG of rectangular multiplied by, and then you sum it up, you'll get some resultant CG over here. So I hope you get what I mean. So you use this concept, and then you can find your position at xb. Okay, the CG of the whole shape. Shape, not sheep. Shape. Okay, shape. 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 Okay. So then we have some discrepancies over here. We don't know whether it's 1 meter or 3.33 meter. I think it's 1 meter lah. But I think it's 3.33 meter or whatever. So yeah, in the future I'll just put a note somewhere over, like, over this video, and then you just can check it out. So I hope I didn't confuse you anything. So the amount of tools are pretty much this easy. So it's just this one, and then this whole equation, and then CG, the concept, and then you have to know how to set your limits, and you need to know how to know which height to use. Okay, which height to use for when we are finding resultant forces for y in the y direction, and then it's just like that. Okay, so the summary is that you have to first find your resultant force, and then you find your location of your resultant force in terms of fx or fy. So maybe in the next lesson we'll talk about how to derive the dam. Okay, so I'm not gonna do this for now. So yeah, so I shall see you in next lesson, which is flow visualization. Okay, and then we'll talk about what other stuff over here. So see you.